Thermal equilibrium is when two systems is brought into contact and energy is transferred from system 1 to system 2. Eventually, the temperature will be the same, and that's what we call the thermal equilibrium. Okay, so let's find out about the experiment.
For this experiment, we need hot water and cold water, a beaker, 300 ml, a small beaker 40 ml, and 2 thermometers. For the first trial, we use hot water 40 ml, and we measure the temperature is 50.
And then for the cold water, we use about 50 milliliter of water and we measure the temperature. And the temperature of the cold water is 23 degrees Celsius. So we put the hot water into the cold water. And then we start the stopwatch. So we wait until both of the thermometer reach the same temperature. So after 5 minutes and 40 seconds, the both liquid has reached the thermal equilibrium.
For the second trial, the hot water we still use 40 ml, and the temperature is 50 ml, as the temperature and the volume are constant.
And for the cold water, we increase the volume to 100 milliliter. And then the temperature is still 23 degrees Celsius. And then we put the hot water into the cold water. And then we start quickly the stopwatch until both of the liquid reach the same temperature or thermal equilibrium. So after 6 minutes and 45 seconds, both liquid have reached the thermal equilibrium because the temperature is same for the both liquid.
For the third trial, the hot water is still 40 ml, and the temperature is 50 degrees Celsius.
And then for the cold water, the amount is 150 ml with the temperature is still constant with 23 degrees Celsius. And then we put the hot water into the cold water. And then we quickly start the stopwatch. And then we wait until the temperature is same or the equilibrium. Yes. So it take 10 minutes 56 seconds for the both liquid to reach the equilibrium. So the equilibrium temperature for both liquid is 30 degrees Celsius.
Turn both.
A lot of boring math later.
Yes, Assalamualaikum and hi. Today we're gonna do an experiment about kinetic theory about Gay-Lussac's law. Okay, so the apparatus that we needed to do this experiment is a container,
Water about
250 ml, candles, a lighter, and some food coloring. Okay, we will do an experiment about Gay-Lussac's law. The Gay-Lussac's law stated that the temperature and the pressure of an ideal gas are directly proportional as long as its volume and the mass is constant. So what we will do now is we will pour this 250 ml of water into this container. Nicely done by Mrs. AKHMA.
Yeah.
Thank you. Alright, then we will put some of the food coloring in the water. And we will make sure that the food coloring is dissolved all in the water. Yeah, like that. Alright, that's enough. Alright. As you can see, it's like this. For the first trial, we will put the candle in the container and then we will lit the candle. Careful with fire. Careful while playing with fire. Alright. As you can see, the candle is lit and then we will put this beaker on top of the candle and we will see magic happens. As you can see, the candle extinguished and gradually and very slowly the volume will increase. For the second trial, we will put another candle with the candle inside with it. And then we lit both of the candles. As you can see, the candle lit, and now we put the beaker on top of it. And see the magic. As you can see, the volume increase.
For the last trial, we put the third candle into the container, as you can see, and then we light up the candle, the 3 candles.
Wow, miracle happens. Okay.
After that, we put the beaker on the top of the candle.
As you can see, the volume increased very rapidly into the beaker.
When the candles lit up and closed by the beaker, the temperature inside the closed system increased as it tried to expand the system, but the system won't because it is a glass, not a balloon. By the candle's flame burn, they use up the oxygen in the beaker for combustion. They producing carbon dioxide and water vapor. As more carbon dioxide produced, it filled up the top of the beaker and forcing the oxygen went down to the system. And gradually the fire is extinguished. As the fire extinguished, the oxygen molecule began to cool off, the losing its excitement causes the amount pressure of a molecule in the beaker dropping. As the air in the beaker wants to be the same pressure as outside of the beaker, this need for balance causes the pull of the water into the system is much easier than the collapse the side of our beaker. The water in our shallow is pulled into a beaker. Raising the water level, equalizing the pressure.